Hello everyone, welcome back to Skill Talk. Today is the fourth video of our vibration series. So now in this fourth video we are going to understand four very important concepts in the vibration analysis. So first topic that we are going to discuss is about what is overall vibration. Second, we will understand about the Crest factor. Third, we will be discussing about vibration spectrum, and in the last we will be covering the what are orders. So basically overall all these concepts form the foundation of the vibration diagnostics. So let's break them down in very simple language. Let's start with our first topic, that is what are the overall vibration readings, right? Let's start with something every technician uses, that is the overall vibration reading, right? So what is this overall vibration reading? Overall vibration reading is a single number, single number that represents a total vibration of a machine, or you can say overall of a particular point. The point can be motor, drive and side bearing, horizontal or vertical or axial, or it can be any of the asset. It can be for pump, gearbox. So this overall reading, or you can say a single number, it does not tell us much about the fault, right? It only tells us that the you can say the how bad the vibration is, what is the condition of the machine, whether the machine is stable or it's the vibration is increased or the overall value has been increased, right? So in industries, typically overall vibration we measure in the velocity. That is very much famous. It's known as the mm per second RMS, right? Because velocity correlates best with the machine health, because most of the overall machines that are in the industry, around 80% or you can say 70 to 80% of machines are falling in this category, where their RPM is somewhere in the mid range of between, you can say, the 400 or 500 till you can say above 500, right? So velocity is a good parameter, or you can say the best parameter that we can measure the vibration of such kind of machines. So that's the reason that why by default in the industries, whenever anyone asks what is the vibration of the machine, so people normally say in mm per second RMS. So let's take one example here. Let's say I am going there to measure measuring the vibration of one of the machine, and I have received the vibration, let's say 2.5 mm per second, right? So normally, as per the standard, let's say the machine, as per the machine specifications and kilowatts and and you can say the RPM, I believe I can say that okay, this machine is normal. Let's say 2.5 mm per second is normal. So next day when I visited that, not next day I will say, but you can say that after a few weeks I visited that machine again, and now my machine vibration is 7 mm per second. So definitely the level shifts from normal to the warning level, right? And let's say after a few more weeks again I went to the machine, and now vibration is more than, you can say, 10 or 11 or you can say 15 mm per second. That means now it's an alarm, it's a time to take shutdown. So these levels you can decide by either using the ISO, that is ISO 10816, or you can just simply follow the trend of the machine. And now why this overall vibration values are important? Because it gives us a quick idea of the machine health, and also we can trend them over a time period. And if I am not any kind of expert or any kind of certified vibration analyst, even then also by looking after the trends, one can easily say that whether machine is running normal or it's moving towards an abnormal stage, right? And also the fourth thing is this, that it's also help us to prioritize that okay, which machine I have to inspect first. Let's say the machine I am monitoring 100 of machines, and out of that 5 machines trends are moving upward. So that means I can just make sure that 5 machine I should inspect, and just keep an eye on that machine, and that those 5 machines I will be prioritized for the maintenance, right? So but overall what we have to remember in the end, that overall vibration is only tells us about the severity. It doesn't give any kind of indication that we can identify which type of fault this machine is having, right? Okay guys, so now let's move to the next topic, that is the Crest factor. Now what is this Crest factor? Okay, so Crest factor is, you can say, the most underrated but powerful indicator. So normally this Crest factor tell us that how sharp or the spiky vibration signal that we are having here. So normally the Crest factor is the ratio of the peak vibration divided by the RMS vibration, right? So if let's say that we are having the low crest factor, that means the sinusoidal is very very close to the smooth sinusoidal waveform, right? So mostly this thing you will seeing in the case of the unbalance. And let's say if there will be a high crest factor, that means there are so many impacts are there inside the time waveform or the spectrum. So whenever we are having the high crest factor, so the most common things that the defects can be towards the bearing defects, or you can say the some kind of a mechanical looseness, or you can say the gear defects, or the defects that is related to some kind of a impacts. This can be the cracked or damaged bearing also, right? So to make it very much clear, let's take one example. Let's say that the machine is having the peak vibration of 40 mm per second, and let's say the another the RMS for that is 10 mm per second. So simply just peak divided by RMS, so your crest factor will be 4, right? So it gives the indication that there are kind of any kind of impacts are present in the machine. So the fault can be bearing related or can be the looseness related, right? So this is how the crest factor will help you to make decisions, right? So what is the key point here is this, that the higher the crest factor is, that means the more impacting the vibration signal is, and if there is a low crest factor, that means it's very almost close to the sinusoidal waveform. I hope the crest factor topic is very much clear. Let's move to our next topic, that is, what is this vibration spectrum? So a spectrum is it's one of the most important tool that is in the vibration analysis. So it shows basically the vibration, it's break down the vibration into different frequencies, right? So the overall reading is, it's like the hearing the you can say the all the sounds and all the stuff together, right? That will give you one overall reading of the vibration. But what spectrum does, spectrum separates them into the specific frequencies. Just let's take an example of this music equalizer, right? Now how this time waveform is converted to the spectrum, I believe we have already discussed in our last videos. So the process is known as the FFT, which is known as the fast Fourier transform. So now what spectrum normally tells us? The spectrum normally tells us about that what frequencies are present in the particular machine, and which component is causing the high vibration. Let's say if the 1x is high, so that means something is related to the unbalance, or maybe something related to the rigidity. So if there will be some 4.2x is high, so that means it's something related to the bearing fault. So like it divides the overall vibration into different frequencies, right? So it helps us to identify that which component is causing the problem, right? And the third is that it will tell us that how much energy is attached to the each frequency. Now the fourth one is this, that what kind of fault is mostly present in the machine. So these are the mainly 4 kind of things that you can easily tell us by using the spectrums. Let's take the example now to make it understand a little bit more. Let's say that in the machine you are getting the first harmonic of the running speed. That means the fault is mostly towards the unbalance, right? So now let's say that you are getting 1x, 2x and also the 3x. That means something related to the misalignment. And let's say if you are getting the GMF, so that means something related to the gears. And if you are getting some kind of a high frequency peaks, that can be multiples of 4.2x or 6 point something, it's a kind of a non-synchronous frequencies. That means it's related to the bearing faults, right? So overall the spectrum is a real detective tool for our vibration analysis process, right? So now let's move towards the last topic, that is orders. So now what are these orders? So orders help us to make vibration interpretation a little bit easy, especially when the machine runs at the different speed. Let's say the machine is driving through the belt drive, right? So what does this order mean? Order mean simply the multiples of the machine running speed. So let's say that the machine is running as 1500 rpm. So 1x, that is the first order, is known. This is how we will be converting the rpm into the orders. So okay, so let's say I'm analyzing any kind of a machine that is running with 1500 rpm. So my first order, or you can say the 1x, will be the 1500, or you can say the 25 hertz. Now if I will check the second multiple, or you can say the second order, or you can say the 2x, that will be around 50 hertz, right? Or you can say the 3000 rpm. So So this is how we will be converting we can convert these spectrums into the orders also, so that it will be very easy for us to differentiate between the peaks, that whether the peak is synchronized or non-synchronized or sub-synchronized, right? So it helps us to identify whether the fault is related to the misalignment or unbalance, or it can be something related to the looseness, or or any kind of a complex vibration patterns. Okay, so the orders are extremely, why it is important? Because they are important because they are independent of the RPM, right? And also the second thing is this, that they will help us to compare the machines. And also the fourth thing is this, they make fault diagnosis faster. Why? Because we can easily say that which peak is synchronous and which peak is non-synchronous, so it make the process faster. So in our latest analyzers, the spectrums can be shown in order domain. Just simply you have to go to the spectrum, open the spectrum, and you can just convert your x-axis into the order domain, right? So it will be very easy for you to identify these patterns. So let's summarize the overall things that we have discussed in today's videos. So we have discussed first the topic, that is the oral vibration, that will tell us about the overall, you can say, the total severity of the vibration, right? And the second, we have understand about the crest factor, that is tell us that whether the spectrum or the time waveform or the machine is having more impacts or it's spiky, So and the third topic that we have learned is about the spectrum, that is spectrum, that is how the time waveform we can convert into the spectrum by using the FFT process, and it help us to identify that which frequency is causing the issue, or which frequency is having the you can say the dominant role in overall vibration. And the last, we have understand about the orders. So orders is simply that converting the machine RPM into the orders, right? So it will help us to easily identify, or you can say our analysis process will become a little bit faster, because we can easily see that which peaks are related to the synchronous and which peak are not related to the synchronous, right? Or you can say the non-synchronous. Okay, so together these tools will give us a crystal clear picture of the machine health. So these are the 4 important topics that we have covered in today's videos. Now I want to come into the last section, that is the challenge that I want to give you all. So let's assume that there is a machine that is showing us the RMS value of 8 mm per second and the peak is 32 mm per second. I would like you all to put in the comment section by putting that question number 1, the answer, what should be the answer, what should be the crest factor of this, right? And the second question that I want to put it here is that, let's say the machine is running at 1800 rpm and it's showing a dominant peak at 30 hertz. So what we will be, what peak we are going to get it here. It is known as the 1x, 2x, 3x, or what it is, right? And the third question is this, that what is the biggest weakness of the overall vibration readings? Okay, so I would like all of you guys to just type your answers by putting 1 dash your answer, 2 dash your answer, and 3 dash your answer. Okay, so in the next video we will be discussing about the phase, that is the most powerful diagnostic tool in the vibration analysis. Until then, keep learning, keep improving, and keep your machines healthy with Skill Talk. Thank you. Bye.